Today's seminar is going to focus on identifying and calculating slope. Our goals and I can statements for this lesson will be: I can identify the slope of a line using a graph, I can find the slope of a line using 2 points, and I can identify the slope of a line as positive, negative, 0, or undefined. So at this time, what I'd like you to do is go ahead and pause the video, title this in your notebook as Identifying and Calculating Slope, write down your goals or I can statements for today. Alright, so what your foldable looks like today is just a half sheet here. So positive slope we'll be looking at, negative slope, 0 slope, and no slope, otherwise known as undefined. If we open up here, we'll notice that we have some graphs and we have some points. So first what we'll be doing is calculating slope using a graph, and then we'll do the same thing with 2 points. So let's go ahead and get started then with positive slope. This is what we'll look at first. So if you open this flap up here, so example 1, it says find the slope of the line shown below. So with the graph, what we want to look at is how we're moving from one point to another. And typically we're going to start at the point that we have furthest to the left. So in this case, it would be the point down here, which is -2, -1. And when you're using a graph, the best approach here is to use rise over run, or you're changing your y, how your y is changing over how your x is changing, kind of like we talked about in function rules. So that typically looks like rise over run. Now let's go ahead and take a peek here and see how this is changing. So we're going to start from this point, and what we're going to do first is move up or down to our next point, and then we'll move right. Typically you can move left or right, but more often than not you're going to be moving to the right. The only time you're moving to the left is if you have to go backwards on your graph, but we're not going to talk about that today. So like I said, we're going to start at this point down here, 2, -1. Or -2, -1, sorry. So we need to, in this case, this is a positive slope. We can see as we go left to right, the graph goes up. It'd be like I'm walking uphill. We're going to see how many spaces we need to move up in order to get to this point here. So if I move up, I see 1, 2, 3, 4. So I know that I need to move 4 spaces up, and that's going to be my rise, so 4. And then I need to see how many spaces I need to move to the right in order to get to this point. Well, when I do that, I see that I move, I'm just going to put an arrow on here, move 1, 2, and then I've ended up at my next point here, which is 0, 3. So we moved 2 spaces to the right, so that's our run. We went 2 to the right. How we moved along our x. Remember, the first part is how we moved along our y, which was +4 and then a +2. With your slope, you always want to reduce it. So 4 over 2 would reduce to 2 over 1, or we could just say 2 in this case. So that would be, and then like I said, this would be a positive slope. And the one way we can think about that is if I move across my graph from left to right, how would I be moving on my line? Well, I'd be going up, right? I'd be walking uphill, so it has to be a positive slope. We'll come back to the points later. We're going to move on to the negative slope, which we'll be doing the same exact thing, just our slope will be negative, like it says. So what we will have here then again is rise over run. And we're going to set that equal to some numbers. So in this case, if I'm moving left to right, I'm seeing my line go downhill. So if I were on this line and walking left to right, I'd be walking downhill. So I know this has to be negative. Another way to think about that is if my point is Or if my line is high in the left and low in the right, it has to be negative. Over here, if I'm low in the left and high in the right, it's positive. So just a couple ways to know whether something is positive or negative. So in this case, for my rise, I'll need to be moving down on my y first. So if I do that, I see 1, 2, 3. So right on the y-axis there I moved. So I know this has to be a negative 3 because I moved down. And then my run would be, I'm moving to the right. So 1, 2. So now I'm at my second point here. So it would be, and I know this is hard to see, but if I'm moving, I go 1, 2, 3, negative, and then I'm moving in the positive direction 2, 1, 2 to get to this second point. So this would be over 2. The next thing we would check here is to see if this is reduced completely, and 3 over 2 or negative 3 over 2 is completely reduced. So that one we're finished with. Our slope of that line would be down 3 to the right 2. Let's check out zero slope then. So zero slope and no slope are kind of special cases, and we'll get into more detail with that in our next seminar, but for now I'll show you how to identify a zero slope. So once again, rise over run. So if I'm thinking about my rise, do I have to go up or down from this point to get to this next point? Your answer here would be no. This is a flat line. So if you ever have a flat horizontal line, your slope's going to be 0. That's a quick way of identifying it as 0. But we can also use our rise over run, or how slope is calculated here, to do this. So we know that we're not going up or down in order to get to our next point. However, we are moving, let's see, 1, 2, 3, 4, 5. We're moving 5 spaces to the right to get from this point on the left to this point on the right. So 0 over 5, if you ever have 0 over a number, it's going to be 0. So our slope in this case is 0. If we were walking on the flat ground, we wouldn't be going up or down. And last but not least, let's look at no slope. This is also known as undefined. So if you wanted to write that on there, you could. And let's take a peek at this one. So rise over run again. Typically, I guess I'd start at the point that I have on the bottom with this, although, so my rise, how do I get from this bottom point to this top point? Well, I'm going 1, 2, 3, 4, 5 spaces up. So my rise is 5. And my run, remember, this is how far I'm moving to the left or right. And typically we're moving to the right. So if I'm going from this point to this point, am I moving to the left or right at all to get there? Well, that answer is no. So this is over 0. If you ever have a number over 0, so 0 in the denominator, it's going to be, well, you can't do that. It's divided by 0 error, but in this case, this would make an undefined line. Undefined. One way to think about this is, if I were to walk up to a wall, could I just start walking up it? Well, the answer is no. So 5 over 0 in this case, and that's undefined. So that's how that would look if you were using a graph. Remember, it's rise over run, so how far you're going up or down between points first, and then how far you're going to the right. Again, you can go left, but typically you won't be doing that. So then, let's move into another way of finding slope. Let's say we're not given a graph, but we're given 2 points that are on the line. So example 2 here says, find the slope of the line that passes through the points below. Well, there's a special equation that we have to use here, and I will write that down. So m, that is the variable that's used for slope. I don't know why they use m, they just use it. So m equals y2 minus y1 over x2 minus x1. And this refers to the points that you have up here, the coordinates that you have. So let's go ahead and label these. So 5, 2, we'll call this x1, and 2, we'll call that y1. And 4, negative 1, we'll call that x2 and y2. Now it's just a matter of plugging in the numbers that we have into the equation below. So let's go ahead and do that. So we'll use m equals, so y2 in this case would be negative 1, so we're just replacing these variables with numbers, negative 1 minus 2, which would be y1, and then x2, which would be 4, and minus 5. Now here's where your integer operations come back in. Like I said, these don't go away, so we need to pay attention to these. Negative 1 minus 2 would be negative 3, and 4 minus 5 would be negative 1. Now we need to make sure that these are reduced completely, and this still falls under the positive slope side. So we're going to want to make sure that our answer is positive. So a negative divided by a negative would be a positive, and a 3 over 1 is just going to be 3. So our slope in this case is 3. Now if you ever end up with something like, let's say up here we have negative 3 over 2, don't write that in a decimal representation, especially when you're referring to slope. You want to keep your numbers and fractions in fraction form, because otherwise it would be really difficult to graph those lines. Alright, moving on then, let's take the same approach here to example 4. So find the slope of a line that passes through the points below. So once again, I'll label these as x1, y1, x2, y2. And I would do this at first so that you don't confuse yourself, because if you do that, you might put the wrong numbers in the wrong place. Now remember, m represents slope. So we're going to use this equation again. So y2 minus y1 over x2 minus x1. Let's do this below here. So m equals, y2 is negative 4 minus 6, and that would be over x2, which would be 5, and x1, which would be 0. So now remember integer operations here. Make sure we're doing these correctly. So if we're doing our integer operations, let's remember keep, change, change, because that's with subtraction. Keep the sign of the first number. Change this to addition, change this to subtraction. A negative 4 plus a negative 6 would be a negative 10. 5 minus 0, well, that's just 5. Now remember, you want to reduce these completely, so negative 10 divided by 5 would be negative 2. You could say negative 2 over 1, but it is just negative 2. So that's our positive slope using 2 points, negative slope using 2 points. Let's take a peek at a 0 slope, remember that's here, using 2 points. Now if we do this correctly, we should end up with 0 in the numerator. So again, let's label these points x1, y1, it's a comma in between, x2, y2. Remember, those are coordinates. And what this equation does is it finds your difference in your y points and the difference in your x points, how far apart they are. So that's exactly what this is doing. So write down our equation again. Remember, m represents slope. So m equals y2, which would be 4. y1 would also be 4, so 4 minus 4 in the numerator. In the denominator, we would have negative 3, because it's x2, minus 4. which would, did I do something wrong here? Yes, I did. Whoops. So negative 3 minus 0. I apologize for that. So you got to pay attention to what you're doing, otherwise you might make a mistake. 4 minus 4 is 0. Negative 3 minus 0 is negative 3. I mean, take anything away from it. Like I said, we should end up with a 0 in the numerator. If you ever have a 0 in the numerator, your slope is going to be 0, or your answer in that case will be 0. So this would be another horizontal line, kind of like it's represented up here. You'd have a horizontal line. And last but not least, let's take a peek at finding a slope using 2 points where it's undefined. So again, let's label our points, x1, y1, x2, y2. And we use the subscripts so we know we're talking about the first set of coordinates and the second set of coordinates. So m equals y2 minus y1 over x2 minus x1. It's good to get in the habit of writing the equation down. That way it helps to commit it to memory. So let's plug in our points here. y2 is negative 2. Y1 is 2, so subtracting 2. 5 would be x2 minus 5, which is x1. We should get, well, on the top, let's remember integer rules. We're subtracting. That's keep, change, change. That applies to any type of subtraction. Keep the sign of the first number, change the sign of the operation in between, and change the sign of the second number. Negative 2 plus negative 2 would be negative 4. 5 minus 5 is 0. So we would have, like I said, if you ever have 0 in the denominator, you can't do that if you're just doing pure division. But if you're dealing with graphing, then if there's 0 in the denominator, then you're going to have an undefined slope. You'll end up with a vertical line. And like I said, we couldn't go up to a wall and just start walking up it without some kind of tools or shoes or something like that. So it's undefined. We cannot have a slope there. So just to recap here real quick, just remember that if you're doing graphs, you want to use rise over run. Start with your leftmost point and then go up or down depending on the slope of your line, and then move to your right. Like I said, you can move to the left, but typically we're just going to be moving to the right. There'll be special times where we need to move to the left, but just think that I need to move to the right. How am I getting to my next point, the second point? So that's rise over run. And then remember, when we're calculating slope using 2 points, label your points. So your first set of coordinates would be x1 and y1. Your second set of coordinates would be x2 and y2. Those correspond to this equation here. Remember, slope equals m. So m equals y2 minus y1. So taking your y2 point, subtracting your y1 point. And then the same thing with your x2 and x1. Subtract, reduce, and that will be your final answer. So make sure that this foldable then gets put into your notebook. Tape it in there. Cutting this out is fairly easy. Fold it in half roughly, cut the strips, and then there's a side strip you got to cut off. But make sure that does get in your notebook, either taped or glued in, so you can refer to it. And just a quick recap then, today we were identifying and calculating slope. Our goal and I can statements are: I can identify the slope of a line using a graph, I can find the slope of a line using 2 points, and I can identify the slope of a line as positive, negative, 0, or undefined. If you have any questions, please ask me. Otherwise, you can always refer back to this video if you are stuck.